Good morning, students. Now let us discuss some numericals from the topic pulley. Page number 59, numericals, example 6. A load of 80 Newton is lifted by applying an effort of 100 Newton in downward direction as shown in the diagram. A. Mark the tension in the figure. Tension always acts in the opposite direction of the weight or load. So in the figure, 80 Newton is the load. It acts in downward direction. So the tension on the string will be in upward direction. On both strands or both pieces of rope, you have to put an upward arrow and write T, capital letter T for tension. Question B. What is VR of the machine? The formula for VR, velocity ratio, is displacement of effort upon displacement of load. In this case, the displacement of the load and effort are equal. It is the diagram of single fixed pulley. In this case, displacement of effort and displacement of load are equal. So, its velocity ratio is 1. Calculate MA. MA formula is load upon effort. Here load is given as 80 Newton, effort 100 Newton. So MA is equal to L upon E. That means 80 upon 100. So 0.8 is the MA value. Now question number D, sub question number D. What is the efficiency? Efficiency formula is equal to MA upon VR into 100. If you multiply with 100, you will get efficiency percentage. So here MA is 0.8, VR is 1 into 100. That means 80% is the efficiency. Now, why the efficiency, next part, why the efficiency is less than 100%? In every machine, efficiency is less than 100% due to the friction or weight of the movable part of the machine. In this case, one reason for less than 100% efficiency is friction of the pulley plus weight of the string or rope segment, which is moving upward together with the load. Due to these two reasons, efficiency cannot be 100%. Next, same page, example 7. In the pulley system shown in the diagram, if an effort of 500 Newton is required to raise the load of 750 Newton, find MA VR efficiency and mark the tension in the figure. Here in the question, load and effort are given. So MA we can calculate by the formula load upon effort. Then velocity ratio formula is displacement of effort upon displacement of load. Look at the figure. It is the diagram of single movable pulley system. Here, if the effort is applied through a distance of 2d, then the load goes up by a distance d. If end of the rope where effort is applied is pulled down by a distance of 2d, load will go up by a distance d. So velocity ratio is 2. Then efficiency percentage formula is MA upon VR into 100. As you did in the previous question, you can find out the efficiency. And tension will be acting on all the three rope segments in upward direction. Now page number 60, example 8. A block and tackle system has 5 pulleys. If effort of 1000 Newton is required to lift a load of 4500 Newton, find MA, VR and efficiency. As you did in the previous question, MA is load upon effort. Both are given. So you can divide load with effort and get the value of MA. Velocity ratio is always equal to the number of pulleys. It has 5 pulleys. So VR is 5. Efficiency percentage, use the formula MA upon VR into 100. Now page number 61, solve these numerical. First one, in the given figure alongside shows a system of 4 pulleys. The upper 2 pulleys are fixed and lower 2 pulleys are movable. Draw a string around the pulleys. Also show the place and direction in which effort is applied. Here there are total 4 pulleys. Total number of pulleys is an even number. So you have to start the rope from this hook, then alternatively from lower block, then to upper block, then to lower block, then upper block, and finally this is the free end of the rope, and here you have to apply the effort in downward direction. Question B, what is the velocity ratio of the system? Velocity ratio is always equal to the number of pulleys, or you can say it is equal to the number of rope segments supporting the load. Here is the load and there are 4 rope segments supporting the load. These are the 4 rope segments. Look at, on all these 4 rope segments tension acts, or these 4 rope segments are pulling the load in upward direction. So velocity ratio is 4. So remember, velocity ratio is equal to number of pulleys or number of rope segments supporting the load. Next question, C. What is the mechanical advantage of the system? Here mechanical advantage you cannot calculate by the formula load upon effort, because load and effort are not given. But mechanical advantage is equal to velocity ratio if the machine is an ideal machine. You assume the machine as an ideal machine, then the velocity ratio and mechanical advantage are equal. Then next part, so MA is also equal to 4. What is the next question? If the load is raised by 1 meter, means displacement of load is 1 meter, through what distance effort is to be applied? Displacement of effort you have to find out. Use the formula VR is equal to displacement of effort upon displacement of load. 4 is equal to displacement of effort unknown, displacement of load 1 meter. So displacement of effort is 1 into 4, that is 4 meter. Next question, state how many strands of tackle are supporting the load. These 4 rope segments, these are the 4 strands of rope segments supporting the load. Now next question 2 on page number 61. The figure given alongside shows a system of 5 pulleys. The upper 3 pulleys are fixed, the lower 2 are movable. Draw a string around the pulleys. Also show the place and direction in which effort is applied. Here the total number of pulleys is 5. It is an odd number. So you have to start from this hook. From here first you have to go to upper block, then lower, then upper, lower, upper. This is the way to pass the rope, and at the end of the rope you have to apply the effort in downward direction. The next question, draw arrows to represent the tension on each strand. So here there are 5 rope segments supporting the load. That means this load will be pulled up by 5 rope segments. And on this rope also there will be upward tension. So everywhere you have to write capital letter T. For tension. Next question. What is the velocity ratio of the system? Velocity ratio is equal to the number of pulleys, that is 5. What is the mechanical advantage? It is also 5 because we assume the machine as ideal one. Now, if the load is raised by 1 meter, that means displacement of load is 1 meter. What is the displacement of effort? Use the formula velocity ratio is equal to displacement of effort upon displacement of load. Displacement of effort you will get as 5 meter. Last one. State how many stands of tackle supporting the load. There are 5 rope segments supporting the load. 1, 2, 3, 4, 5. These 5 rope segments are pulling the load up. Now page number 61, questions based on ICSE examination. Fifth question. A fixed pulley is used to draw water from a well. A force of 72 Newton has to be applied to pull a bucket with water in it, weighing 6 kg. If G is 9.8, calculate the mechanical advantage of setup. Mechanical advantage formula is load upon effort. Here effort is given as 72 Newton. Load we have to find out. The load lifted is a bucket with water. Its mass is given 6 kg. So weight of the bucket together with water, that is the load, is equal to m into G. 6 into 9.8 Newton. That is the weight of the bucket together with the water, same is the load. So you have the load here and effort here. Divide load with effort, you will get the mechanical advantage. Now take page number 63. Additional numericals, 11 questions are given. For all, we have done the sample one. You try these numericals in your notebook by yourself. There is one correction with the question number 10. A pulley system has 5 pulleys in all and is 75% efficient. Calculate MA, effort required to lift a load of 1875 Newton. Remember, load is printed as 875, that is wrong. Load is 1875 Newton. Correct it. The calculate C part is resistance due to the movable parts of the pulley system. So first part you have to find out MA. Load is given and there are 5 pulleys in all. So VR is 5. Efficiency is 75%. That means 0.75 in decimal form. Then MA you can calculate. MA is efficiency into VR. You know the formula, efficiency is equal to MA upon VR. So MA is efficiency into VR. So efficiency is 0.75, VR is 5. So you will get MA as 3.75. Next part, you have to calculate the effort. Use the formula MA is equal to load upon effort. MA you have, load you have, so you can calculate effort. Now C part, resistance due to movable parts of the pulley system. Here MA is equal to VR if the machine is an ideal one. Okay, so we assume the machine as ideal one. Then the formula will be MA is equal to total load lifted is L plus X upon E. we assume the machine as ideal, so MA will be 5. Then load lifted is L. X means that is the resistance due to movable parts of the machine. So L plus X will give the total load lifted. Total load lifted is useful load plus resistance due to movable parts of the machine. So 5 is equal to L is given as 1875 plus X upon effort. Effort is calculated already in the previous step. That effort you can write here, then find out X value. So try all these exercise questions, numericals, everything in your copy. Okay, thank you.